Thank you for being here. We are Group 2, and the members of Group 2 are Bhuvan, Aditya, Harsh, that's me, Khushi, Priyanka, and Neelraj. Today, we'll be presenting a project on AI portfolio optimization for the course Finance Information Processing. Through this project, our goal was to explore how artificial intelligence can help investors build portfolios that adapt more effectively to real-time market conditions. Next slide, please. Yeah. We began this project asking an important question. What if an investment portfolio could adjust to market changes in real time? Most traditional financial methods rely on static formulas and assumptions about how markets behave. But real markets are dynamic, unpredictable, and filled with nonlinear patterns. Our approach uses deep learning to move beyond assumptions. Instead of predicting prices, the model learns directly from historical patterns and adjusts portfolio weights dynamically. The outcome we optimized for is the shape ratio, which measures risk adjusted returns. This allows the model to produce smarter, more adaptive investment decisions tailored to today's fast moving financial environment. To understand why AI is needed, it's important to examine the limitations of modern portfolio theory. MPT assumes that asset correlation remains stable, returns follow a normal distribution, and historical averages can reliably predict future behavior. Our AI model solves these issues by detecting complex, nonlinear patterns that traditional formulas miss. Instead of relying on fixed assumptions, it identifies which asset combines, maximize, and Sharpe ratio under evolving market conditions. In simple terms, AI allows the portfolio to learn from the market itself rather than from outdated assumptions. Over to Neil Raj.
Yeah. So the plan was to gather raw data of stocks, commodities, bonds, etc., and then do some cleaning, feature engineering on top of that. Basically, a data model that can be used for training a machine learning model. Once the data is trained, we will extract the weights for each of the sector, asset, area it is trained on. Since the loss function and the objective function tries to minimize the risk and maximize the return, we will normalize the weights and allocate them for the portfolio. In order to achieve this, we use these technologies. We used Python, JavaScript, CSS, HTML for front-end and back-end for the project. For version control, we used GitHub and DVC. We used Django as a back-end framework to make and design API calls. Coming to the libraries, we used Pandas for data cleaning and transformations, PyTorch for training, and most importantly, Stook and YFinance to fetch the data. And finally, for API testing, we used Postman. I'll pass on to Bhuvan to explain more about feature engineering and machine learning modeling.
Hi everyone, I'm Bhuvan. Coming to the presentation, as Neil previously explained, we have fetched the data using Stook and Yahoo Finance. We were able to fetch the past 10 years data collectively of the SP 500 and commodities data, and we have around totally approximately around 2.7 million records of them, and the data which we have collected is of the format OHLCV, which stands for Open High Low Close and Trading Volume. These data is required for us because it gives us the data which is required for us to calculate the sharp values which are required for this project. And coming to the areas where we have collected the data, we have collected the data of SP 500 and the US commodities. And for example, the SP5 under the SP 500, we have the data of industries, information technology industries, materials industries, and energy, power, finance, etc. And coming to the commodities, we have the US general commodities like wheat, gas, and oil, crude oil, and silver and gold. Coming to the data set, the processing we have done on that, like here I'll walk you through the how we have prepared the data and what are the feature engineering we have done. First, we normalize the price. It means we have scaled the prices so that the model sees relative movement rather than the original raw dollar values. This removes the scales of different companies and gives equal opportunity to each one. Next, we just added a simple features that can capture trend and risk. For the trend, we used moving averages. It smooths the short-term variations or the short-term noise and highlights the directional momentum. For risk, we used volatile differences, a simple high and low difference, which reflects price discrepancies in the given point of time. Finally, we split the dataset into testing and train splits of 70/30. In short, here we normalize for stability, feature engineered a few high signal features for trend and risk assessment, and we use splits to measure the generalization. This made us keep the pipeline simple and robust. Next slide, please. Yeah. Here, coming to our model snapshot, we have chose a simple three-layer model. Here, our CNN model has feature extraction stage, temporal aggregation stage, and a decision head. The first two convolutional blocks scan the time period to learn how the short-term patterns are there across the assets and sectors. Next, we use adaptive average pooling, compressing each asset's window into a clean and fixed length signal. Lastly, the two fully connected layers learn how the nonlinear interactions between the assets and different sectors work together, which signals to prioritize. And finally, the decision head softmax turns the score generated into valid allocation percentages. Next, the Harsh will be explaining the results of the model.
Okay, here we are looking at how the model Sharpe ratio evolves during training. The blue line represents the training Sharpe ratio, while the orange line shows the validation Sharpe ratio. Both curves are, are trending upward over time, which tells us that the model is consistently learning to improve adjusted returns. The training starts lower but gradually climbs as the model identifies useful allocation patterns. The validation sharp stays strong and stable throughout, indicating that the model is generalizing well and not overfitting. Towards the final epochs, both curves converge around the 0.14 to 0.16 range, showing that the model reaches a stable and improved solution. Overall, this graph demonstrates that our deep learning model is effectively optimizing the Sharpe ratio and improving performance with each epoch. Next slide, please. Now let's look at how the model performs across different datasets. We tested four asset combinations: stocks and commodities, commodities only, stocks only, and then gold and IT. Here are the key insights. Stocks and commodities achieve a Sharpe ratio of 0.31 with a risk level of 19.44%. Commodities alone perform slightly worse with a Sharpe ratio of 0.28 and moderate risk. Stocks alone mirrors the risk and Sharpe ratio of stocks and commodities together. This is because stocks data is quite volatile and the model finds it hard to deal with volatile data. The standout performer was gold and IT, achieving the highest Sharpe ratio of 0.47 and the lowest risk at 11.29%. This tells us something important. The model identifies that combining a defensive asset like gold with a high growth sector like IT produces the best risk adjusted returns. I'll hand over to Neilraj for the demo.
Thank you, Harsh. Let me share my screen. So this is a dashboard or the home screen for our project. On the left side, we have data of stock market and commodities for the performance overall since 2016. So the user can compare any multiple industries or sectors that he is interested in, and he can see their performance for past 5 years, 1 year, like that. And he can hit the reset highlight button to, reset everything that he selected. On the right side, we have asset classes similar to what we have on the left, but with the return, annual return like 1 year, 3 year, and 5 years. So once we expand a particular asset, we'll have the list of sectors that Bhuvan have told in one of the slide. So we have communication services, IT, utilities, like that. In the commodities too, we have gold, silver, copper, steel, some things like that. So the user can track the performance, and based on the performance, annual performance, he or she can select few sectors that he's interested in creating a portfolio with. I'm just going with silver, natural gas, gold, energy, and IT. Once the user clicks create a portfolio, in the backend, what happens is that uh, the CNN model that Bhuvan described will be trained with the data that user selected. So once it has allocation, it normalizes the weights to a distribution where we get 100% allocation to the capital. So here's what we have selected: IT, energy, and commodities. And in commodities, we have selected gold, natural gas, and silver. So for this particular combination, for this particular allocation, the annual risk is quietly high. It's 19% yearly, and Sharpe ratio is quite bad. So this is what the model has a best combination with. So on the right side, you can see a pie chart describing the allocation. It says that majority of your capital went should be into IT, and followed by commodities with silver, gold, and natural gas, and then energy sectors. So let's see the portfolio now. So the major one to invest in is silver with nearly 11%, and then analog devices, API Corporation. We have Accenture also here. We have Broadcom, Adobe, Autodesk, Apple, companies like that. So this is one way of creating a portfolio. If user is not very sure about selecting few sectors, they can go to a composite portfolios, which means these are already predefined with some heuristics on the risk and return side. For example, for the conservative, which is only based on the risk, minimizing the risk mostly. So this is a portfolio that he has to invest in. So similarly, balanced, a default model that we earlier used to train the model, it tries to balance between return and risk. Here we have, it says that invest 22% into the silver and followed by natural gas, IT, and all. So coming to the aggressive portfolio, which focuses on immediate returns and not really care about the risk. So here's what so it says that invest more into silver, like 26%, and more into natural gas and all. So we have a risk of 16.9%, which is highest of uh, the other portfolios. But the weekly and monthly performance are relatively better than the balanced and conservative. I'll hand over to Bhuvan to conclude the project presentation.
Coming to the conclusion, the main takeaway is we have successfully built a CNN-based portfolio optimization system. It automatically generates and assets weights from market data. The stocks and commodities combination has a Sharpe ratio of 0.31. The gold and IT combination has a Sharpe ratio of 0.47, which is okay, but we can improve it more. The model is not up to date in terms of volatility capturing the volatility of the market. So our future scope would be making a better AI model building on this and adding more data related to US bonds, treasuries, and cryptocurrencies, and also including our news data categorized by industry level and company level to make sure that we have a very good portfolio optimization system, and also adding supply chain and macroeconomics. The next slide is all the references we have used to build this model. These are the references you can go through for knowing more about our project. And thank you.
Thank you.
Thank you. I think it was